I hope I'm audible and visible properly.
Yes, sir.
Is the screen visible, guys? Is the screen visible, all of you?
Yes, sir, it is.
Yes, sir.
Right. So I'm really sorry. So we have seen some questions yesterday, I guess. I hope. Right. So I think we have discussed till here, guys. So why is trajectory of proton less curved? I hope you understood that. Right.
Yes, sir.
Yesterday we were doing some question. I hope you got this. So some very simple questions we have discussed yesterday. We will try to complete all the questions till whatever time I can discuss. Right. If I'm not feeling sleepy and all, till whatever time I can discuss, I'll continue to take the session, guys. Okay. I hope you will be ready for that. And maybe we can have some long sessions also. But as I said before, so I've already lost my almost like my throat is gone and all. Right. But still I'm taking the session, and certainly in future, please don't worry, we will have long sessions also, guys. Okay. So whatever, if there is any lagging left behind, obviously we will complete that. You just trust me, and I'll certainly complete all the things, guys. So we'll just move on to the other questions. So equal current I flows in two segments of circular loop as shown in the figure, it seems. Right, radius of the loop is a, magnetic field at the center of the loop due to the segment, only ACV part they are asking. How much part, beta? Only this part. So you see how much angle it is going to subtend over here. Total angle is 360 degrees. We need to take the angle in radians, guys. Total angle is 360 degrees. So this angle dotted will be 2 pi minus theta or not, guys. Right? And we know what is magnetic field at center due to a complete circle. It is mu naught I divided by 2r. Due to part of a circle, what will it be? Theta divided by 2 pi. So here you see how is the sense of current clockwise. So when the sense of current is clockwise, you will curl the fingers in the sense of current. Direction of thumb is going to give us the direction of magnetic field at that particular point. So how is the direction? Inwards. So what will that magnetic field be at center, beta? Only due to ACB part they are saying. So how much is it going to be due to ACB part? It will be mu naught I divided by 2a. How much angle is subtended by ACB part at the center? It is 2 pi minus theta divided by 2 pi. So what will be the answer, guys? The answer should be second option. Mu naught I by 2a, 2 pi minus theta divided by 2 pi. When will it be 0? When will it be 0? I think you all remember. Suppose if I say some current is entering, same current is coming out. So here when current gets divided, when current gets divided, then I can say magnetic field at the center will be 0. But in this case, magnetic field will be mu naught I divided by 2a, 2 pi minus theta divided by 2 pi. And where will that direction be, guys? Along the sense of current, we'll curl the fingers of the right hand. Direction of thumb will give us direction of magnetic field at that point, which is minus k cap. Clear, all of you? Yes or no? And as I said before, magnetic field will follow principle of superposition. If I want to find magnetic field at any point, guys, it will be vector sum of magnetic field due to all the current carrying elements present in the system. Just like electric field. Electric field at any point will be vector sum of electric field due to all the charges present in the system. In the same manner, magnetic field at any point will be vector sum of magnetic field due to all the current carrying elements present in the system, guys. So that on based on that, we are going to have our next question again. You see magnetic field at point O they have given. Magnetic field at point O due to the given structure is how much they are saying. Due to this structure. So I current is flowing here and I current is flowing here. So what I'll do is I will divide this structure into two parts, guys. One will be semi-infinite wire because it has a you can consider it is fixed at this point. It is a semi-infinite wire, guys. Other will be a semicircular arc you can consider, semicircular current carrying element. So let us imagine this is our first current carrying element. Let us say this is second current carrying element. So due to first, we are interested in calculating magnetic field at center. So is it a case where we are interested in calculating magnetic field due to a semi-infinite wire where the point is exactly opposite to the other end or not, guys? Is it opposite to the fixed end? So did we study this case? Yes, we have studied. So what will B1 bar be, beta? It will be mu naught I divided by 4 pi A. What is it going to be? Mu naught I divided by 4 pi A. One angle will be 0, other angle will be 90. So is it mu naught I divided by 4 pi A or not? So where will the direction be, beta? See, sense of current is to the right. So what will we do? In the direction of current, we'll place the thumb. Point is bottom. So in the direction of current, we'll place the thumb. Tangent to the curl of the fingers at the given point. Where is it pointing, beta? Inwards. So you'll get it as minus k cap. Is that clear? Am I visible properly? Whatever hand directions I'm showing, are they visible, guys?
Yes.
Right. Next, what is magnetic field to second part? It is semicircular part. So how much is the angle subtended by semicircular part, beta? It is going to subtend an angle, how much? Pi radian. So what are we going to get here? Mu naught I divided by 2a. How much is the angle it is subtending? Pi divided by 2 pi. What is the direction again? You see, sense of current is clockwise. So along the sense of current, curl the fingers of your right hand. Direction of thumb, where is it again? It is inward. So what I'll get again? I'll get it as minus k cap. So what is the resulting magnetic field? It will be vector sum of magnetic field due to all the current carrying elements. So what will this be, beta? Mu naught I divided by 4 pi a minus k cap plus mu naught I divided by, can I write 4a minus k cap or not? So if you take mu naught I divided by 4a common, if I take, guys, mu naught I divided by 4a common, what will I get here? 1 by pi plus 1 minus k cap. Is that clear, all of you? Is that clear, everyone? Understood or not? Let's move to the next question, guys. What they're asking us magnetic force on the current carrying wire of length L placed in a magnetic field as shown. So what is magnetic force experienced by a current carrying element? I into L bar cross B bar. If I want to find the magnitude, beta, what will I get? I into magnitude of L bar cross B bar. So what I will write it as? I into L into B into sine theta. Yes or no? Now you see. How will you take direction of L bar? Direction of L bar will always be taken in the direction of flow of current or not? Yes or no? So current is flowing in this direction. So L bar is also along positive x-axis. B bar is also along positive x-axis. Here, what is the value of theta? What is angle between L bar and B bar, beta? 0. So what will sine theta value be? 0. So what is the magnetic force experienced by the current carrying element, beta? It will be 0. Clear? Yes or no?
Yes, sir.
Yes, sir.
Or is holiday for you people, guys? I don't have holiday. That is why I'm asking.
No,
This holiday
sir.
है हॉलीडे तुम लोगों को?
No, sir.
मेरे को है क्या देखना हॉलीडे पहले. मेरे को हॉलीडे रहे तो अच्छा रहता. कॉलेज एज यूजुअल है कहते. एक हॉलीडे मिल गया तो अच्छा था. ठीक है. Next question. A straight wire of mass 100 grams and length 50 centimeters carries a current I. It is suspended in a mid-air by uniform horizontal magnetic field. So how is the magnetic field, beta? It is something like this. It is suspended in mid-air. What is the magnetic field they're asking? Now, if you take a wire, I'm just showing it as point, guys. Let us say I'm just showing it as point. What are the forces that are going to act? First and foremost, will weight be acting vertically downwards or not? Yes. If it is freely suspended, if only weight was acting, it will move down under the effect of gravity. But I want to just make it sure that it is staying like this only. So weight is acting vertically downwards. There should be one force which will, what will it do? Counter the weight. And which force will that be, beta? That force has to be your magnetic force. The magnetic force I need to get in upward direction. When will I get magnetic force in upward direction? How should the current be, guys? Uniform horizontal magnetic field, they have said, no? So can I say horizontal means it can be, see what is horizontal plane? XZ plane is a horizontal plane. So either it can be x-axis or it can be z-axis, guys. So let us take a wire, something like this. I am taking wire in this manner, guys. Let us say this is the wire. Magnetic force I want in this direction. Let us say it is carrying current I in this manner. So is it going to follow L cross B or not? So I want L cross B to be upwards. So what we can tell about magnetic field, beta? Magnetic field should be inwards. This is our magnetic field. Clear? So length vector is this. Magnetic field if it is inwards. So see, length vector is like this, guys. Yes or no? Length vector is like this. Magnetic field is in this manner. So if I do L cross B, are we going to get magnetic force in upward direction or not? Yes, we are going to get. So is the magnetic field horizontal? Yes, it is horizontal. See whether it is along x-axis or z-axis. Magnetic field will be horizontal only, guys. Okay. So what we can write here, the magnetic force will counter weight. What is magnetic force? I into L into B into sine theta should be equal to mg beta. Here length vector is along x-axis, magnetic field is along z-axis, so theta value will be 90 degrees. So what we can write here, I into L into B into sine 90 will be equal to mg. They are asking us to calculate magnitude B. I can write it as mg divided by IL. What is mass beta? 100 grams is given. So 100 into 10 power minus 3 I'll write. So can I directly write it as, okay, 100 into 10 power minus 3 we can write. G value you can take it as 10. I value is 1 ampere. Length is 50 centimeters. So I can take it as 50 into 10 power minus 2 beta. So what are we going to get? Will I get this as, this numerator will be 1 or not? And this I can send it as 100. 10 power minus 2 if I send it to numerator 100 divided by 50. So you will get how much beta? 2 Tesla will be the magnetic field. Clear?
So could you show the hand movements once again? So, which you showed right now?
Kya?
So could you show the hand movements once again, which you showed right now?
Hand.
So could you show the hand movements once again, which you showed right now?
रुक भाई एक मिनट रुक. Can you please talk now? Hello.
Yes.
Now it's night. You please tell.
So could you show the hand movements once again, which you showed right now?
Hand movements.
Yes, sir.
अरे यार क्या डांस करूं क्या अब तुम्हारे वास्ते? Right. See, what is the meaning of horizontal plane? It is XZ plane. Magnetic field, they are saying it is horizontal. It means it can be along x-axis, it can be along z-axis. Either positive x, negative x, positive z, negative z. It can be anything. Let us assume that wire is placed like this. Wire is placed along x-axis. What are the forces? Weight. Suppose if only weight is acting, what will happen? It will fall down. But they are saying the wire is suspended here. So weight should be countered by a force called as magnetic force. So I want magnetic force in upward direction. So when will I get magnetic force in upward direction? L cross B is magnetic force. So L bar will always be taken in the direction of current. So I have taken L bar along which axis? I cap. Magnetic force is along J cap. So I cross what will be J? I cross minus K will be J. Yes or no? So that is the reason magnetic field will be taken perpendicularly inwards. Clear?
Yes, okay.
Next. In a toroid, the number of turns per meter length is 500 per 1 meter, it seems. Current through it is 1 by 2 pi ampere. Magnetic field produced inside will be how much they are asking. See, basically, I think we know solenoid. What is magnetic field due to a solenoid? If it is a long solenoid, guys, will I write it as mu naught Ni? Any point you take inside, it is mu naught Ni. Which can I write it as mu naught Ni divided by L or not, beta? Yes or no? Now, when solenoid is made into a circular shape, it is going to become a toroid. So length of the solenoid. So what is magnetic field of a toroid, beta? The length will become how much? Length will become circumference 2 pi r. So what is given to us? Number of turns. 2 pi r is again nothing but per unit length only. N by 2 pi r is given for us. So what they are asking? They are asking us to calculate magnetic field. The mu naught value, it is 4 pi into 10 power minus 7. What is number of turns per unit length beta given as? 500. What is the current flowing through it? 1 by 2 pi. So what will I get? 2 pi, and you will get 2 here. So 2 and 500 will be 1000. 1000 into 10 power minus 7, you will get it as 10 power minus 4 Tesla. Clear, everyone? If you take a solenoid of some finite length and you are converting into a circular loop, the solenoid will become a toroid. Means length of the solenoid will get converted into circumference of the toroid, guys. Clear, all of you? This is 2 Tesla, I think. This is 10 power minus 4 Tesla. Are yaar, yes or no?
Yes, sir.
Yes, sir.
Question, let us see. Tomorrow we'll start magnetism and matter. Day after tomorrow I'll end it. So I think we are lagging by 2 chapters, I guess, guys. So that I'll try to complete on Sunday. Okay. ये test का ना इसलिए I think we are getting late because of that. Mm, today is what? 13th, right? Yesterday you were supposed to write test. You will be writing it 2 days later. आज day क्या है भाई? Yesterday only magnetism and matter was supposed to be completed. Okay. So I think we'll be falling short by 2 chapters, guys. But I'll try to cover those in some or the other way. Tests will be conducted as it is, right? Everything will be conducted as it is. Again, because I am feeling strained, guys, because of travel, fasting, and all. So hopefully we'll cover everything, right? But maybe as of now, we are currently lagging by 2 days, and I'll cover that on Sundays or something like that. The radius of a circular current carrying coil is R. At what distance from the center of a coil on its axis, the intensity of magnetic field will be 1 by 3 root 3 times the center. What is magnetic field at center? We know it is mu naught I divided by 2 capital R. What is magnetic field at axial point, beta? They're asking at what distance from the center of coil on the axis. Axis is nothing but passing through center and perpendicular to the plane. How much is it? Mu naught by 4 pi 2 into I into pi r square. Do you remember this? 2 m bar divided by r square plus x square whole power 3 by 2. Yes or no? Do you remember it, guys? What they are saying? Magnetic field at axial point. These fellows are saying magnetic field at axial point is 1 by 3 root 3 times the magnetic field at center. So if that is the case, they're asking what is the value of x. So what we can write here, dekho, very simple. I can cancel out pi and pi, 2 and you'll get 2 again. Okay. So what will I write magnetic field at axial point as? Mu naught by 2 I into r square divided by r square plus x square whole power 3 by 2. Okay. This will be equal to 1 by 3 root 3 times magnetic field at center kya hai bhai? Mu naught I divided by 2r. Is that clear? So what we can cancel out from this? 2, 2 gaya, mu naught also gaya, I and I also gaya. So what are we going to have now? So I can write r cube will be equal to, yes or no, r square plus x square whole power what beta? 3 by 2. So if I just do cube on both sides, this is anyhow by 3 root 3 is also there. 3 root 3 r cube you can write beta. Clear, all of you? What is 3 root 3 r cube? Is it 20 root 27 or not? 3 power 3 by 2 can I write? So what is this? This is 3 power 3 by 2 into r cube. I want to remove the square root. So on both sides, I'll multiply by 2 by 3 beta. So r square plus x square whole power 3 by 2. I want to remove the square root, so on both sides I am multiplying 3 by 2. So what are we going to get? Cube, cube, cube cancelled. Right here, cube, cube gaya, square, square also gaya. So what will be left out on left hand side? 3 power 1 by 2 is there. 3 power 1 by 2 whole square is there, guys. So I will get it as 3r square or not. Will be equal to r square plus x square. So 2r square value will be equal to x square. What will x value be beta? Root 2 times of r. So at how much distance will magnetic field be 1 by 3 root 3 times of the center? At root 2 r. Understood? Yes or no? Basic formula, guys. Direct questions you will get from formulas only in moving charges and magnetic effects of current. Did you understand, everyone? Yes or no? Sir, formula గుర్తులేదు సార్ అని చెప్పకండి. I hope I'm audible to all of you.
Yes.
Particle of charge 2 microcoulomb is at rest, it seems. In a magnetic field is inwards. Magnetic Lorentz force on the charged particle with respect to an observer moving with velocity 4 j cap will be how much they are asking. With respect to observer, where is observer moving? Again, observer is moving with the velocity where beta? Upwards with speed 4 meter per second. Now, how is the magnetic field? Magnetic field is given inwards. How much is the magnetic field beta? It is 3 minus k cap. What is the charge? Positive charge is given, which is 2 microcoulomb. Some charge q you can write. Okay. Some charge q you can take. Now, what is the meaning with respect to observer? What is the meaning of with respect to observer, guys? What do we do if with respect to observer is taken? It is relative motion. With respect to observer means first step. What will I do to observer? अरे क्या करना है भाई? We are going to just stop the observer. What all quantities are there to observer? I am giving it to charge. In which direction? In opposite direction. So please tell me, what is the velocity of charge with respect to observer? It will be 4 minus j cap. What is the magnetic force experienced, beta? You all know magnetic force experience will be q into v bar cross p bar. What is the charge? 2 microcoulomb. You can write it as 2 into 10 power minus 3. Sorry, minus 6. What is velocity of the charged particle with respect to observer? It is in downward direction. How much is it? 4 minus j cap cross. What is magnetic field, beta? 3 minus k cap. Is that clear, all of you? So what is 4 3 is 12? 12 2 is how much? 24 into 10 power minus 6. Minus into minus will be plus. J cross I, what is it going to be, beta? J cross k, sorry. It is going to be I cap. So the magnetic force experienced by the charged particle will be along positive x-axis. 24 into 10 power minus 6 I cap. Clear? Yes or no? With respect to ground, charged particle is at rest. Velocity is 0 means there will not be any magnetic force. With respect to ground, 0. But with respect to observer, it will experience 24 into 10 power minus 6 newtons. Clear, everyone? Yes or no, all of you? I hope it is clear. Right? Next question. Negative charge q moves along parallel to a very long straight wire. The direction of force. See, how is this straight wire? Is it carrying current in upward direction? Where is the point charge? To the right. Please tell me, how will the magnetic field be? How will you calculate direction of magnetic field to a wire? In the direction of current, place the thumb wherever the point is, tangent to the curl of the fingers. So where is the point here? Here. So the magnetic field will be inwards. So is it a charge moving in which direction? Upward direction. So velocity is upwards, magnetic field is inwards. What is magnetic force? V q into V cross B. So if I do V cross B in the direction of velocity, place your right hand, curl the fingers towards magnetic field. Are you going to get the direction of V cross B along negative x? But which charge it is? Because this charge is negative charge. What will I do? Whatever direction of V cross B I am getting, I am going to just reverse that particular direction, guys. Whatever direction of V cross B I am going to get, that I am going to reverse it. So what is the situation here? The force is going to act along positive x direction like this. So along OX will be the magnetic force beta. Clear everyone? If it was a positive charge, opposite to x. But because it is a negative charge, you will get a force opposite to the direction of V cross B. How did I find the direction of magnetic field beta? Again, because current is being carried upwards. Current is carried upwards means place your thumb in the direction of current. Tangent to the curl of the fingers at the point will give direction of magnetic field. So this point, magnetic field will be inwards. It has velocity upwards. Magnetic field is inwards. If I do V cross B, I'm going to get negative x. But because it is negative charge, I need to reverse this direction. I'm going to get the force along OX beta. Clear everyone? Yes or no, yaar?
Yes, sir.
Let us see next question. Electron accelerated through a potential difference. Electron accelerated through a potential difference V passes through a uniform transverse magnetic field. Experience a force F. If the accelerating potential increases to 2V, the electron in the same magnetic field will experience a force. How much they are asking? So initially, let us say initial kinetic energy. Kinetic energy can be written as charge times of potential difference between. So I can write it as Q into V. Yes or no? Yes or no, guys? Now what is kinetic energy here? I can write it as half mv square will be equal to V initial square. Let us say Q into V. What will V initial square be? 2QV divided by M. So what is V initial beta? Root over 2Q capital V divided by M. Yes or no? Now what has happened to the accelerating potential? It got increased to 4V. So what will be the final speed beta? Root over 2Q into this will be 4V divided by M or not. Charge is not changing, mass is not changing. So what will I get this as? Root 4 will be 2 again. Will it be 2 times of root over 2QV divided by M beta? So what is the final speed? It is 2 times the initial speed. Right? So electron accelerated through a potential passes through a uniform transverse magnetic field, experience a force F. So initially you can consider it experiencing a force F. Now if the accelerating potential is increased to 4 volts, if accelerating potential is increased to 4 volts, what has happened to its speed? It got increased by 2 times. So what is the magnetic force? Initial magnetic force, you can say it is QV initial into B. What will be final magnetic force? QV final into B. I can write it as what is V final? 2 times of V initial into B, guys. So I can write it as 2 times of Q into V initial into B, which is 2 times of FB FB initial, guys. Is that clear? The force will become 2F times. Understood all of you? When accelerating potential is increased by 4 times, speed will get increased by 2 times. If there is no change in magnetic field, no change in charge, force will also get increased by 2 times. Clear everyone? Yes or no?
Yes.
Yes. Which of the following graph shows the variation of magnetic induction with radius of current carrying circular loop? It seems. Direct question again. What is magnetic field at the center due to a current carrying circular loop? Mu naught I divided by 2R. So as you can see, magnetic field at center is it inversely proportional to R? So whenever Y is inversely proportional to X, which graph will it follow? It is going to follow a rectangular hyperbola. Clear, everyone? Second option will be the answer for that. Understood? Right. Current carrying power line. Current carrying power line carries current from east to west. Okay. So if I take north, south, east, west, where will north, south, east, west lie? In horizontal plane, beta. Always be very careful with this. North, south, east, west. Where will it lie? In horizontal plane. So this is our north, this is our south, this is our east, this is our west. So a current carrying power line carries current from east to west. So is it carrying current in this direction or not? Is carrying current in this direction. The direction of magnetic field at a short distance vertically below it. Now they're asking where, beta? They're asking here at a short distance vertically below it. Point P is here. So let us say it is at a distance x. So you assume that it is a long wire. Current is along negative x direction. Point is along negative y direction. So what will I do? Again, very simple logic. In the direction of current, place the thumb. Point is below, guys. So in the direction of current, place the thumb. Tangent to the curl of the fingers. Where is it pointing? Outward or not? So it is directing towards the south. So where will the magnetic field be? Your magnetic field will be something like this, beta. How much is it going to be? Mu naught I divided by 2 pi x. If I take it as a infinite wire. So how is it directed? It is directed from north to south, beta. Clear, everyone? Understood? North,
Yes, sir.
south, east, west will always lie in a horizontal plane, guys. Okay. Positively charged particle enters magnetic field with a uniform velocity. If the angle between velocity and magnetic field is 180, what is the trajectory? Already told, no? Theta is 0 or 180, straight line. Theta is 90 degrees, circular path. Theta is some arbitrary angle, it is going to follow a helical path. Yes or no, beta? So here it is going to follow which graph? Straight line graph. Yes or no? Whenever V bar is parallel to B bar or V bar is anti-parallel to B bar, what will be magnetic force in both of these cases? In these both cases, magnetic force will be 0. Magnetic force is 0 means there is no force which will change the motion of the object. If it is traveling in a straight line, it will continue to go in that same straight line. Clear, everyone? Yes or no? Again, Ampere circuit law, let us see. Integral B bar dot dl bar for the loop as shown in the figure they are asking. Now I don't know the sense of the loop. Let us take sense of the loop to be clockwise. So when sense of the loop is clockwise or you take anti-clock, it's up to you guys. Okay. When the sense of the loop is clockwise, what will you do? Along this sense, you will curl the fingers. All those currents in the direction of thumb should be taken as positive, and all those currents opposite to the direction of thumb should be taken as negative. You can take the sense anyway, guys. Okay. So what will I get here? Integral of v bar dot dl bar over closed loop will be mu naught times of what is net current, you see? Since I have assumed clockwise, then obviously, will I consider this current? No. Why? Because it is not lying inside the loop, guys. I'm not going to consider this current. Right? Which current should be positive? Now, because sense is clockwise, inward current should be positive. So I can take this as plus I. Okay, plus I'm going to take this as minus 3I. Plus I'm going to take it as minus I. Yes or no, everyone? So what will happen? I'll get it as mu naught into I minus 3I minus I, which I'll get it as minus 3 mu naught into I. So wherever minus 3 mu naught I. So I have assumed clockwise sense. Maybe he has taken anti-clock and written. Magnitude will be 3 mu naught I, guys. Clear, everyone? Yes or no? Should I current 2I current out? Should I consider 2I current outside? No, I need to take only those currents which are inside the Amperian loop. Amperian loop can be any arbitrary shape, but usually we take circular shaped Amperian loops, guys. Understood? Yes or no?
Yes.
Right. Next question, you see. What they are saying, a charged particle moves through a magnetic field perpendicular to its direction. So here velocity vector is what? Perpendicular to magnetic field. What is path followed? What is path followed? Circular path. And it executes which motion, beta? Charged particle executes uniform circular motion. So as it is executing uniform circular motion, what will remain constant, beta? Speed will remain constant. Right? Speed is constant. You can also say kinetic energy is constant. But what will keep on changing? Velocity will keep on changing in direction. Momentum will also keep on changing in direction. In magnitude, they will remain same. Both momentum and kinetic energy of particle are constant. Correct? No. Kinetic energy changes, but momentum is constant. Correct? No. Momentum changes, but kinetic energy constant. Correct? Yes. Clear, all of you? How is momentum changing? The speed is constant, kinetic energy is constant because they are scalars, guys. Right? Velocity is changing. So how is velocity changing, beta? It is going to change only in direction. In magnitude, so anyhow it will remain same. So if velocity is changing, automatically what we can say? Momentum is also changing. Momentum is changing. How is it changing? Again, momentum is also changing in direction only, guys. Clear, everyone? Yes or no?
Yes.
Are you getting the access to videos, recorded videos?
Yes, sir.
Let us see the next question, guys. Circular coil carrying a certain current produces a magnetic field B naught at the center. Again, it is very important case. Coil is now rewound so as to have 4 turns and the same current is passed through it. Now, very simple logic is, dekho, you take some wire, guys. It has some length L. Again, directly against it becomes n square times, but how it is becoming, let us see, guys. It has some length L. I am converting it into a circular coil of 1 ton. Let us say its radius is capital R. So in this case, what we will write length as? Length I will write it as 2 pi r. Yes or no, everyone? Now what I am doing, the same wire, what I am doing, now I am converting into this turn. But like that, how many turns I am taking? I am taking 4 turns such that radius of each turn is small r beta. Now in second case, how will I write the length as? For each turn, you will get 2 pi small r. Like that, how many turns are there? 4 turns. Here, what is capital R value? L divided by 2 pi. Here, what is small r value, beta? L divided by, or you can say, you can write 1 by 4, L divided by 2 pi. You can write it as R divided by 4. Right? We know magnetic field at center. What is magnetic field at center? If we talk about magnetic field at center due to a loop, guys, circular loop, we know it is mu naught I divided by 2R. This is for 1 turn only, guys. Like that, if I have n turns, let us say, then it will be given as n into mu naught I divided by 2R for a loop of n turns, guys. So for a loop of n turns, it will be n into mu naught I divided by 2R. Is that clear? Now please tell me, in first case, magnetic field is given as B naught. So what we can write? B naught value will be, we know mu naught I divided by 2R it is. Now in second case, what will it be? Due to 1 turn, it is mu naught I divided by 2 small r. But like that, how many turns we have, beta? We have 4 turns. So into 4 I will do. And what is small r value? I can write small r value as r divided by 4. So 2 into capital R by 4 into 4. So 4 fours you will get 16 or not? 16 into mu naught I divided by 2r. What is already mu naught I by 2r? it is B naught. Okay. So very important, very important case, guys. If one length you have, one wire you have taken, and it is giving us some magnetic field. If the same wire is now made into n turns, right, then magnetic field at the center will become n square times. Blindly you can remember it. Is that clear? Only one turn magnetic field, let us say, is given as B. Right? If you are taking n turns, guys, magnetic field will become how many times? N square times. So what will the answer be for that? 16 times of B naught. Is that clear, everyone?
Yes, sir.
Right. Now, same current is flowing in three infinitely long wires along x, y, and z direction. The magnetic field at point 0, 0, A. It is, I think, a package question only, I guess, again. You take it something like this. X, Y, and Z. I am assuming currents to flow along positive x. So I have same currents flowing. You have one like this. You have one like this. Sorry, positive Z they have said, no? All are positive only, no, guys? Right. So you can imagine the current is flowing like this. I, this is I, this is I. And they're asking us to find, this is anyhow center, guys. They're asking us to find at this point, which is 0, 0, A. So I have three wires over here. This is our, let us say this is our first wire. This is second wire. This is third wire. I want to find magnetic field at a point. How will you find magnetic field at a point? Magnetic field at any point will be vector sum of magnetic field to current carrying elements or not, guys? Now please tell me, where is this third, for due to third wire, where is the point lying? Where is the given point lying? Is it lying on the third wire or not? So whenever a point is lying on the on the wire or on the wire produced, what will be magnetic field at that point due to that wire? Zero. We have studied this or not, guys? So what is B3 bar here? It will be 0. Now I want to find B1 bar. All will be infinite wires. So current is in upward direction, right? The point is here, outward. So what will I do? In the direction of current, place the thumb tangent to the curl of the fingers. See, in the direction of current, I have placed the thumb tangent to the curl of the fingers at the given point. Tangent to the curl of the fingers will point along x-axis beta. So this will be our magnetic field due to our first current carrying wire. Then current is like this, second current carrying wire. Point is here. So what I'll do, in the direction of current, I'll place the thumb tangent to the curl of the fingers. It is going to point in which direction, beta? It will be pointing in downward direction like this. This is our B2 bar. Clear? So how can you write the point P? Coordinates were given as 0, 0, A. It means the perpendicular distance from any wire you take, whether you take x coordinate wire, x axis wire, or y axis wire, the perpendicular distance will be A only. Is that clear? So what is magnetic field due to Y current? I can write it as mu naught I. So I mean it is completely infinite wire. Mu naught I divided by 2 pi A. In which direction we got? If the current is in upward direction, if point is lying on Z axis, you will get it along positive x beta. So I will get it as plus I cap. What is magnetic field to second wire again? If current is carrying along positive x, if point is towards positive z, you will get the direction in downward direction. So what will it be? Mu naught I divided by 2 pi A. Downward direction will be minus j cap. So what will the answer be? You can take mu naught I divided by 2 pi A common. You will get it as I cap minus j cap. Direct question, guys, again. Clear, everyone? Yes or no?
Yes, sir.
Right,
Yes,
direct
sir.
question. Let us see the next question. Galvanometer can withstand safely a maximum current of 10 milliampere. It is converted into voltmeter of range 40 volt, connecting in series an external resistance of 3880. What is the circuit Will it become like this or not? Galvanometer is there. Resistance of galvanometer is there. In order to convert into a voltmeter, I need to add some resistance or not in series. Now this particular reading of voltmeter is given as how much beta? 40 volts. And how much current can the galvanometer withstand? It will be able to withstand a current of 10 milliampere. How much is this resistance connecting in series and external resistance of how much beta? Is given as 3880 ohm. A galvanometer can withstand safely a maximum current of 10 milliampere. It is converted into voltmeter of range 40 volt. So let us imagine the resistance is this. How much current is flowing? I current is flowing through two resistors. Are they in series or not? Yes. So what we can write beta? The voltage reading. I can write it as I into G plus R. They are asking us to find G value beta. So what will G value be? You can write it as V by I minus R. V is how much? 3880 divided by 10 milliampere is given. So I can write 10 into 10 power minus 3. Minus resistance is given as, sorry, V is given as 40, no yaar. Voltmeter reading is 40 minus 3880. So will I get 10 power minus 2 in denominator? 10 power minus 2 in denominator means it will become 10 power 2. 4000 minus 3880 you will get, which will be 120 ohm. So the resistance of galvanometer should be how much beta? Should be 120 ohm. Clear everyone? So or no?
Yes.
In the given figure, an electron enters into a uniform magnetic field. If it is deflected in which direction? Again, direct case, V cross B. Velocity along x-axis, magnetic field along z-axis. So V cross B will be upwards. But what is the charge beta? Negative charge. So where will the force experience on it? It is going to experience in downward direction, which is negative y direction. Clear? Yes or no? Direct question again. Next case. To obtain radial magnetic field in a moving coil galvanometer. In order to obtain radial magnetic field, we are going to use concave shaped poles, guys. How do I obtain concave shaped poles? If the poles are cut cylindrically. So the reason for obtaining radial magnetic field is by introducing concave shaped poles. And how will we obtain concave shaped poles? Very simple logic. While if I take a new box of ice cream, guys, right? And if you pick up one scoop, so you will be left out with some spacing given. So that would be concave phase, guys, right? So in order to get a radial magnetic field, we are going to make use of concave shaped poles. How do you obtain concave shaped poles? They are going to be obtained by cutting it from cylinder. Clear? So or no? Next. A magnetic field due to a small current at a distance r bar and element current I is given by how much they are asking. What is the answer for it? Fourth option or not beta? Mu naught by 4 pi dl bar cross r bar divided by r cube. If I want to write in magnitude, mu naught by 4 pi I dl sin theta by r square. Clear? By Sawat's law. Yes or no?
Yes, sir.
Next question. A circular coil is made from a wire of length 1 meter. If possible, we'll have more time in tomorrow's class, guys. Maybe 2.5 hours we can take tomorrow, if possible. Okay. Tomorrow we can take, definitely. If my voice supports also. A circular coil is made from a wire of length 1 meter. When a current passes through it, what is magnetic moment? What is magnetic moment given as? We know it is given as I into A bar. If I want to write only magnitude, it is I into A. Yes or no? So I value is how much beta? Pi. And what do we write the area? Is it pi r square or not? It is made from a wire of length 1 meter, it seems. Length is 1 meter. So what will length become? Will length become equal to circumference or not? So what will r value be beta? L divided by 2 pi. Here it is 1 divided by 2 pi. So what are we going to get? Pi into 1 by 2 pi whole square I am going to get. Yes or no? A circular coil is made from a wire of length 1 meter. When a current pi ampere passes through its magnetic moment. So is it I into A only or not? Circular coil will have how much radius? Pi r square. So I'll get it as pi square into 1 by 4 pi square I'll get or not, guys? 1 by 4 వస్తుంది కదరా నాకు. Is there any mistake that I have done? A circular coil is made from a wire of length 1 meter. Length is 1 meter means radius will be 1 by 2 pi. So 1 by 4 pi square only you'll get. So it should be 1 by 4 only, guys. Yes or no? So you change it, huh? 1 by 4 you take. Clear? Understood, everyone?
Yes.
Oh. Two long straight parallel conductors are kept 20 centimeters apart, carrying currents 4 ampere each in the same direction. So whenever two parallel current carrying wires are carrying current in same direction, which type of force will be developed between them? Which type of force, beta? Carrying current in same direction. Attractive force will be developed. If they are carrying current in opposite direction, you can say they are carrying same current, guys. They are asking us to find out what is the magnetic induction midway between them. So let us say from here to here distance is how much? R. From here to here also distance will be how much? R. So let us imagine this is first wire, this is second wire. So in which direction will be magnetic field at the given point due to the first wire? Current is in upward direction. So tangent to the curl of the fingers will be inwards, guys. So what are we going to get? Magnetic field B1 if I take. Magnitude also I write, guys. Because it is a which wire? Infinite wire. So I'll get it as mu naught I divided by 2 pi r inward direction. We can write it as cross. Clear, everyone? Now, due to second wire, you see, current is in upward direction, point is here. So in the direction of current, place the thumb. Tangent to the curl of the fingers will point outwards. How much will be B2 bar again? You will get mu naught I divided by again 2 pi r. Where is this direction? Outward. So what is the resultant magnetic field, beta? It will be vector sum of magnetic field due to all the current carrying elements. So are they both same in magnitude? Yes. Are they opposite in direction? Yes. So what is the resultant magnetic field at the midpoint? It will be 0. Clear? Is that clear, all of you?
Yes, sir.
Clear, everyone?
Yes.
Next. A 20 electrovolt electron is circulating in a plane at right angle to uniform magnetic field. So how is it circulating? Perpendicular to the magnetic field. The orbital radius of electron is nearly how much? Energy is given, guys. So what is the radius here? mv divided by qb we can write, or we can write it as root over 2mk divided by qb. Yes or no? So what will this become? Root over 2 into what is mass of electron? What is mass of electron, beta? 9.1 into 10 power minus 31 kgs. What is kinetic energy? 20 electrovolt is given. So if I want to convert into joules, I'll write it as 1.6 into 10 power minus 19 joule. Clear? Whole divided by Q is what? 1.6 into 10 power minus 19. What is magnetic field? 2 into 10 power minus 4. Clear, all of you? So you see what is 31 and minus 19? Will it be 40, will it be 50? Here 2 into 2 you'll have 4. Under root of 4 will be 2. So in numerator I'll get 2. Root over 9.1 I'll approximately take it as 3. I already have 10 left. 10 into 1.6 will be 16. Under root of 16 will be 4. into 10 power minus 50 you have, under root of it will be minus 25, divided by, what will I get this? I can write it as 2 into 1.6, 2 into 1.6 into 10 power minus 23 I can write. So 2 and 2 gaya kaam se? 4 ones 4, you will get 0.4 beta. So 30 by 4 you will get. So I can take 30 by 4 as how much? 7.5 into 10 power minus 2 meters, which I can write it as 7.5 centimeters. Clear? Clear everyone?
Sir.
Doubt? Gauss is unit of what beta? Tesla and Gauss are units of magnetic induction. One Gauss is 10 power minus 4 Tesla, guys. Maxwell will be unit of magnetic flux. Magnetic moment anyhow is ampere meter square only. An electron enters a region where magnetic field and electric field are mutually perpendicular. Okay, so what I'll assume magnetic field to be inwards, beta. What I'm assuming, magnetic field, how is it? Inwards. And I'm assuming electric field to be downwards. Are they mutually perpendicular? Yes or no? Yes or no? Or let us say, okay, you take it downwards only. Electric field is in downward direction. Now you see, they are saying electron. What are they saying? Electron. Is it negative charge? It enters a region where magnetic field and electric field are mutually perpendicular. So let us say it is entering with some velocity. It is entering. So this electron will be under whenever negative charge particle is placed in external field. What is it going to experience? Electric field if it is placed, guys. Is it going to experience a electric force opposite to the direction of electric field or not, beta? And if you do V cross B, velocity is along x-axis, magnetic field is inwards. If you do V cross B, are we going in upward direction? But because it is negative charge, will you throw it in downward direction or not, guys? So here, while electron is moving in perpendicular electric field and magnetic field, it will be under the influence of two forces, beta. E into V into B also we can write, right? So it is moving something in this manner. So it is under the influence of two forces. If these two forces are equal, then what will happen? It will continue to move in straight line. Yes or no, all of you? Yes. So will it undergo undeflected? Is there a possibility? Yes. It will always move in the direction of magnetic field, it seems. Is it possible? No. It will always move in the direction of electric field, it seems. Is it possible? No. Is it possible, guys? No, not necessary. It will always possess circular motion. Possible? No. So there is a possibility that it may move undeflected, guys. So with what speed I should project? I should project it with a speed equal to velocity selector E by B. If I am projecting it with that speed E by B, then there is a possibility that it may move in crossed fields without getting deflected or deviated. Understood? Is that clear?
Sir,
Ji sir.
sir, if magnetic field is more and electric field is less, is there any possible of moving circular or
It,
it is
no, it will not. See, if electric field is more or magnetic field is more, let us say, if electric field is more, let us say, compared to magnetic force I am saying, not field. If electric force is more compared to magnetic force, then you will get a net force in upward direction or not. So there may be, it may perform circular motion if it is always perpendicular again, or it may follow a parabolic path. In the same manner, if magnetic force is greater, it may follow a parabolic path or it may perform circular motion. But they are saying it always possesses circular motion. Is it correct? No, it depends on the strength of electric field and magnetic field. There is a possibility that it may perform circular motion or parabolic path, projectile motion. Understood?
Yes, sir.
Charged particle of charge q mass m enters perpendicularly in a magnetic field. Kinetic energy of the particle is E. What is time period? It seems. What is time period, beta? Direct again. 2 pi m by qb or not? It is not going to depend on radius, neither it is going to depend on speed. Yes or no, all of you?
Yes, sir.
Magnetic force acting on a charged particle of charge minus 4 microcoulomb. Charge is negative. It is velocity is given, guys. So what is given to us? Velocity is given as I cap plus 2j cap into 10 power 6 meter per second. And how is magnetic field given as? It is given as in x direction they have given. Then can I say 3 I cap Tesla? They're asking what is the charge given? It is minus 4 microcoulomb. Right? What is the magnetic force acting on it? So can I do V cross B? What is V cross B, beta? I cross I, 0 again. J cross I, minus K cap or not? So 2 into 3, you will get it as how much? 6 you will get. J cross I will be minus K cap. This is V cross B. What will magnetic force be? Because it is negative charge, I'll directly write it as charge times of V cross B. I'll take the charge as it is, beta. Minus 4 microcoulomb is given into 10 power minus 6. Here also velocity was given in into 10 power 6 was there, guys. So I can write it as 6 into 10 power 6. You can consider. In which direction we got? J cross I we got, no? J cross I is minus K cap. This much V cross B. Now what will this be? Charge is 4 microcoulomb they have given. So minus 4 into 10 power minus 6. What is velocity, beta? What is V cross B we got? 6 into 10 power 6. So what will this be? Minus 24 you will get. So minus 24 means in which direction will it be? Minus K cap or not? You will get it as minus K cap, guys. So what will it be? It will be 24 K cap. So how much force will it experience? It is going to experience 24 Newton in Z direction, guys. Understood all of you? Or no? Next, it's also very important question, previous year question only, guys. A charged particle is accelerated through potential V naught, is subjected to a crossed electric field and magnetic field. The electric field and magnetic field are crossed, guys. The fields are adjusted such that charged particle is not deflected. So whenever we are projecting the charged particle into crossed fields, how are we projecting? Let us say again we are projecting it perpendicular to both electric field and magnetic field. So let us say electric field is along positive x direction, magnetic field is along z direction, negative z. How are we projecting the charged particle? It is perpendicular to both electric field and magnetic field. They are saying the field are adjusted such that charged particle is not deflected. So when we are projecting a charged particle into crossed fields, I should project it with the speed E by B such that it will not get deflected. Clear all of you? So what is E value given as? Anyhow, it is given as E only. And this you can write it as B only, guys. So you can take it as this only. But how can I write V value as? Because I don't have speed given. I have stopping potential given, guys. What we can write V value as? Speed, how can we write? Just now we know kinetic energy can be written as how much, beta? Charge times of V naught. So I can write half mv square value as charge times of V naught. So what will I get? Q by m value if I take. What will Q by m be? V square divided by 2 V naught. What is Q by m, beta? This Q by m happens to be specific charge of the charged particle, guys. So did we already get V value? Yes, this V is called as velocity selector, beta. How much did we get? E divided by B whole square divided by 2 V naught. So I'll get it as E square divided by 2 V naught B square. Clear? Is that clear? So whenever electric field and magnetic field are perpendicular to each other, I am projecting another charged particle again perpendicular to both electric field and magnetic field. there is a possibility that it may move undeviated. When will it move undeviated? If we are projecting it with a speed equal to E by B, and that speed is called as your velocity selector. Is that clear, all of you? Is that clear, everyone? So you'll get it as E square divided by E square divided by 2V naught into B square. Clear? Next case you see. Magnetic force on a current carrying semicircular loop in a transverse magnetic field. I told you current carrying semicircular loop is given. We know magnetic force by current carrying coil or current carrying element plays in an external field. It is given as I into L bar cross B bar. Yes or no? Yes or no, guys? And I said I can also write it as B into I into L effective. Okay. So they have given something like this. So they are asking us, let us take between 2 points, guys. Any 2 points you can take. Magnitude only they are asking. So between these 2 points, between the ends, let us take this is A and this is B. And let us imagine it is carrying some current in clockwise sense. So how can I replace this as? I can replace it with a rod whose length is how much, beta? Whose length will be equal to, what will the length be? Will it be equal to 2 times the radius or not? So what is the effective length now? It will be equal to 2r, carrying current in which direction? Upward direction. In which magnetic field is it placed? Again, you can consider it is placed in a transverse magnetic field like this. So what is the force they are asking, guys? So what will the magnetic force be? See, length vector is along y direction. Magnetic field is along z direction. So what will I write? B into I into L effective directly I can write, or usually B into I into L sine theta you are going to get, guys. So here, what is L effective value? It is 2r. So what will I get? The magnetic force as B into I into 2r, which is 2BIR. Clear? Understood? Yes or no? I hope it is clear, guys. Let us see next question. There is a long straight wire of radius r carries a steady current I. The current is uniformly distributed over its cross section. So is it a solid conductor or not? Magnetic field at a distance 2a by 3 from its center. Is it inside or not, guys? So what is magnetic field inside the solid current carrying conductor? We know it is given as mu naught I divided by 2 pi capital R square small r. Yes or no? So what is the radius given as? I think radius should be given as A. So you can make a small correction here because R is not given. So you consider this radius as A beta. So what will I get? Mu naught I divided by 2 pi A square. What is the distance from center? Because distance is 2a by 3, it is less than A, right? So what will you get? You will be finding magnetic field inside. How much is it? 2a divided by 3. So what we can cancel out? A and square will be cancelled out. 2 and 2 will be cancelled out. So what will you get magnetic field as? Mu naught I divided by 3 pi A will be the magnetic field. Is that clear? Is that clear, all of you?
Yes.
Let's see the next question. They're asking us, the figure shows current loop having semicircular arc joined by two radial lines. The magnetic field at point O they're asking. So I'll divide into four categories, guys. So this is your straight wire, first category, semicircular arc, again straight wire, finite straight wire. Then you have again fourth part. So what is magnetic field? We know principle of superposition. It will be B1 bar plus B2 bar plus B3 bar plus B4 bar. Yes or no, everyone? Now please tell me, the given point center, is it lying on the first line produced or not? So whenever a point is lying on the current carrying wire produced, what is magnetic field at that point due to that particular wire? 0. If you see third wire also, is the given point lying on the third wire produced beta? Yes. So magnetic field due to third current carrying wire will also be 0. How is the sense of current in second? Is clockwise. So whenever clockwise current is there, direction will be inwards. So how much will I get here? Mu naught I divided by 2 into what is the radius of third part? R. How much angle? Because it is semicircular, it will subtend pi angle divided by 2 pi. In which direction beta? Minus k cap. Plus, what is magnetic field to fourth part? Again, it is also semicircular loop, but it is carrying current in anti-clockwise sense. So whenever loop is carrying current in anti-clockwise sense, direction will be outward, guys. What will I get? Mu naught I divided by 2r. Again, it is subtending. Sorry, it is not 2r. What is the radius here, beta? Radius is again 2r, beta. It is subtending pi angle divided by 2 pi. But where is the magnetic field? Plus k cap. So what we can do? You can just write it as pi and pi will get cancelled. You will get it as mu naught I divided by 4r minus k cap plus mu naught I divided by how much will I get? 8r k cap. You can see the magnetic field inward is more, guys, compared to out. So you will get this overall, you will get it as, if I take the LCM, you will get it as mu naught I divided by 8r in minus k cap direction. Clear, everyone? Yes or no? Mu naught I by 8r will be the answer. How will the magnetic field be? Inwards, perpendicularly inwards, guys. Yes. Path of a charged particle entering in a uniform magnetic field making an angle 60 degrees with the field. Velocity is making an angle theta. So what will be the path followed, beta?
Helical.
It is going to follow helical path. Right. A ring of radius r and mass m has charge q uniformly distributed on it. It will rotate with angular velocity omega, magnetic moment. There is one ratio called as gyromagnetic ratio. Which ratio, beta? Gyromagnetic ratio. What is this ratio given? The ratio of magnetic dipole moment to the angular momentum. M by L will be given as Q divided by 2 small m. What is M here? M is your magnetic dipole moment, guys. Or you can simply write magnetic moment. What is L here, beta? L happens to be your angular momentum. L happens to be what? Angular momentum. What is Q? Q is your charge. What is M? M is your M is the mass, guys. So what are they asking us to find? They're asking us to find what is the magnetic moment of the ring. So I can write capital M value as Q by 2m into L. Now, angular momentum, we go back to system of particles, guys. Please remember, there are two types of angular momentum. One will be due to the effect of translation, called as orbital angular momentum. Other will be due to the effect of rotation, called as spin angular momentum. So here ring is only rotating, guys. So we will talk about an angular momentum called as spin angular momentum. It is given as moment of inertia into angular speed. So what we can write it as Q by 2m. What is moment of inertia for a ring? Again, it is mr square beta into omega. So we can cancel out m and m. What will the answer be? It will be qr square omega divided by 2. This is our magnetic dipole moment. Clear, all of you? Understood, everyone?
So here we are considering spin angular momentum.
Yes. Why? Because only rotation is there.
Okay.
And majority of the cases, ring is there or disk is there. If it is rotating, what is magnetic moment? It will basically be rotating. You should consider spin angular momentum only. Okay. Now, a charged particle moves in a gravity-free space without change in which of the following is not possible in space, it seems. They're asking which of them is not possible in space. Let us try to understand, guys. Okay. All the four cases I'll make you understand because they are important again. So let us take a charged particle. I don't want any change in velocity. Let us say it is moving in this manner. First case is what? Electric force is 0. Electric field is 0. Implies, will there be an electric force? No electric force. Magnetic field is also 0. Implies, what will be magnetic force? 0. So from this, what we can tell about net force beta? You know, net force will be vector sum of electric force and magnetic force. Aja. Okay, I'll show you one person. I have seen him after a long time. Abuji, he is my nephew. ये कौन है? देखो कौन है? क्या करे मामा? क्या करे? हेलो बोलो सबको, हेलो बोलो, हेलो 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 बोलो, हेलो बोलो, अगुन हेलो हेलो बोलो, जल्दी बोलो, नहीं बोलते? कहाँ हो बेटा आपको? चलो आते मामा, आते जाओ, अब भी आ रहे हैं, 5 मिनट में आ रहे हैं, जाओ जाओ नानू, जाओ नानू, जाओ नानू, नानू जाओ। नहीं जाते नानू, नहीं जाते, मामा रहते, जो नानू जाओ। मामा रहते, आ रहे, मामा आ रहे हैं, चलो जाओ। आ रहा हूँ, हो गया हो गया। ये क्या देख रहे हैं? अच्छा जो आ रहे, मामा आ रहे हैं, चलो आए मामा, आपके पास से चाहिए, जाओ। ओह ओह ओह, जाओ जाओ। He was sleeping by the time I came. Am I audible, guys?
Yes, sir.
Right. So in first case, is there any net force? No. So again, law of inertia, basic law of inertia. Object at rest continues to be in the state of rest. Object in motion continues to be in the state of motion until unless there is an external force acting. There is no force acting. So in this case, will it move in the straight path or not? Yes. So in first case is possible, right? Change in velocity without moving, without change in velocity, it can be moving, guys. Second case, if you see, electric field is non-zero. So obviously, electric force will also be non-zero, right? Right. Now, magnetic field is 0. If magnetic field is 0, then automatically magnetic force will also be 0. In this case, net force will not be 0, guys. It is non-zero, right? So it can move in a straight line. Suppose let us just change the question. Can it move in straight line or not without getting deviated? So it is possible for it to move in a straight line because this is a charged particle. Second case, if I take, let us say this is a charged particle. It is moving with some speed v. Charged particle is q, let us say. Now electric field is in the same direction like this. So if electric field is in the same direction, what will happen? Will it experience a force in the direction of field? Yes. So what will happen? It will move with more speed. So here in this case, beta, speed will increase. Whereas if I say, if electric field is in opposite direction, it means because it is a positive charge, it will experience a force in opposite direction. So velocity and acceleration will be in opposite direction. In this case, it will be moving again in straight line only with decreasing speed. Okay, so first case it will move in straight line. Second case also, let us say it is moving in straight line, but they're asking without change in velocity. In second case, definitely there will be change in velocity. It may either increase or decrease, guys. Okay. Third case, you see. What is third case given, you see? So obviously we have already come to the answer. The answer is second option, guys. Right? Second option is the answer. Third case, anyhow, if I explain. What will I get? Electric field is 0. Iska matlab, definitely electric force is 0. They are saying magnetic field is non-zero. Now what is the meaning of this? Even if magnetic field is non-zero, let us say, third case if I'm taking, charged particle is here beta. Let us imagine velocity is along positive x direction. Let us also imagine magnetic field is in the direction of magnetic field is in the direction of velocity applied, or if it is opposite to the direction of velocity applied. In this case, can there be force? Again, here in this case, magnetic force can be 0 or magnetic force may not be 0 also. When will it not be 0? If magnetic field is perpendicular to velocity, guys, or at a certain angle. So here in this case, net force, if we talk about, net force may be 0 or net force may not be 0. So there is a possibility that net force will be 0. If net force is 0, it is a possibility it will be moving without change in velocity, guys. Then fourth case again. What is the fourth case? Talk about fourth case. They are saying electric field is non-zero. इसका मतलब definitely electric force will be there, guys. And they are saying magnetic field is also non-zero. It means again two cases. Magnetic force may be 0 or magnetic force may not be 0. Right? Now, net force, if I take C, if magnetic force is 0, there can be only electric force. So there can be net force. If these both forces are non-zero but in opposite direction, can they cancel out or not? So again, in this case also, net force may be 0 or net force may not be 0. Fourth case, if I take, guys, let us take a charged particle, right? You are considering a positive charged particle because it is easier to understand. Let us say it is moving along positive x direction. So you have a magnetic field inwards and you have electric field in downward direction. A positive charge, will it always experience force in the direction of electric field? So you can say electric force is in this direction. Beta. Now if you do V cross B, velocity is along x direction, magnetic field along z direction. V cross B if you do, are we able to get a certain force which is magnetic force in upward direction or not? See, I'm not saying that they both should be equal, but if they are equal, again, the charged particle will be moving in a straight line without change in velocity. These are the four very important cases that you need to know, guys. So third option also can be moving without change in velocity. Beta. So which case change in velocity will not be there? In second case, right? Either speed may increase or decrease. Clear, all of you? Is that clear? Yes or no, guys?
So when magnetic force is equal to 0 and electric field is there, would it perform a parabolic motion?
Magnetic force 0?
When magnetic field is 0 but electric field is there, won't it perform a parabolic motion instead of straight line?
It can perform. Again, if electric force is perpendicular to velocity, it will follow parabolic. But if electric force is in the direction of velocity, it will follow straight line motion only.
Yes, sir.
Now, if they gave, in which case straight line is not possible, none of the options will be correct because in every case straight line is possible, guys. Straight line with change in speed is possible. So in all the cases, there is a possibility that it can move in straight line only. Clear?
Yes.
Understood, all of you? These were some questions of your moving charges and magnetic effects of current. Tomorrow we'll discuss magnetism and matter. If possible, we will discuss entire magnetism and matter tomorrow itself, guys. Okay, by taking maybe 2.5 hours or so like that. Any doubts in this, all of you? I didn't write the answer for this. What is the answer for this? Not I by 3 pi a. What we got? What mu not I by 3 pi a, guys? Okay. Is that clear, all of you? All the questions? These were moving charges and magnetic effects of current. What I feel is magnetism is more easy compared to electrostatics and current electricity, guys, usually, right? Because questions directly will be asked from formula based questions only or a very little practical approach, guys, right? So personally, if I were a student, I would have given magnetism more priority than electrostatics or current electricity. Okay, any doubts, guys, all of you? Whatever doubts you have, tomorrow before beginning of magnetism matter, let us complete those. Tomorrow will definitely take extra time, guys. Okay, clear, all of you?
Yes.
Hello, thank you. Take care, everyone. Bye bye, all of you.
Thank you,
Thank
sir.
you guys. Take care.